Thanks for coming. I'm excited to share my research. And one of the things I wanted to do today was to showcase a new methodology called Epistemic Network Analysis. It actually has the capability of taking qualitatively coded transcripts, written or audio, and quantifying it into a graph that actually demonstrates privately held knowledge or beliefs. And my research is situated in K-12 teacher education and professional development for urban teachers. I'm interested in looking at how they think and believe in problem-based learning instructional practices before and after professional development, and then most significantly, how those instructional best practices impact student learning. The field is STEM, and the specificity is engineering design. So what I'd like to do is to talk to you and showcase ENA with 3 studies, using middle school students, 3rd and 4th graders, and kindergarten students, saving the best for last. So I wonder what these groups of students know about engineers and what they do and engineering design. So Epistemic Network Analysis was designed by David Schaefer at IU Wisconsin-Madison. He was trying to figure out how to capture cognition and measure it within a community of practice, and he was looking at e-learning environments. The questions I posed to those groups of participants are, what do engineers do? How do they impact society? And how do they know when they've created something that it's successful or the product is finished? So ENA looks like this. We can see here that there's 3 ideas. D3 is that people buy things. So this person said that engineers design things so that D3, people can buy them. They buy things such as D5, which is technology, cell phones and computers, and they also buy things like infrastructure, such as buildings, bridges, and roads. So middle school student research study, I started looking at how can I determine in a large group of students who knows how much? Can we classify these graphs of cognitive thought in terms of novices who have a small amount of knowledge, few connections, to competents that have more, to experts that have denser graphs? So this is a novice graph. We can see few ideas. We can see that B1 is connected to B2, which means that engineers build and design, and that's connected to the largest thought of E2, which is that they do it through asking questions. When we look at a competent graph, you see more ideas, a little more connectedness, but you still see the strongest code because of the thickest line is from engineers build by asking questions. We can tell here the expert graph because it has so much more content knowledge held and that it's denser and more connected. And we still see B1, they build through asking questions, but we can see in the upper left C2, which is the idea that engineers test and retest to design a product. In B4, slowly in there you can see B4, that's the idea, advanced notion, that engineers not only build things, but they build and design innovative ideas. So then we had 3rd and 4th graders from Beveridge Elementary in the Gary schools come here for a 2-week summer camp in 2017, and they were involved in a 2-week engineering STEM summer camp. They were in their school and they first decided projects that they wanted to do to change their school for the better. So they came for 2 weeks, and I want to share some of the things that they learned. This student learned that engineers talk about things a lot and they plan, being the strongest concept. But they also realized that engineers, after those 2 weeks, they make rules, they build, they love to build stuff, and how do they know when a product's done? When it's working. And also, they improve our world by building and painting, which is what they did when they were here. This student's strongest held idea was that engineers envision first, they draw, and then they build. But all of that is tied to negotiation. This student's strongest idea was that engineers negotiate in order to build. And they do these things. They draw, they build, here's the things they build, and they have to agree. Kindergartners, the best part, they were given a pre-test and a post-test, so I can actually share with you knowledge construction over time. They had 5-week unit in the fall of 2018 and a 5-week unit in the spring of 2019 on engineering design principles and what engineers are and do. So I have pre and post. So this student did not have enough information to have E&A make a graph, but we know that they thought that they make stuff like experiments and they learn new things. But after those units, they were able to articulate and construct knowledge that engineers improve our world by growing food, that they fix things, and that when they're building something, they try again, and that, you know, they can tell when it's done because they just look around and they can tell by looking. This student had a graph, but the graph talked about the fact that engineers know stuff, and they do like explosions. And so explosions could be considered perhaps a stereotype or even a misconception. And amazingly enough, this student traded in that for the one to the right, which is actually that engineers solve problems. And they actually talked about identity, a computer engineer, and how they knew it was done. Well, you know, they just always know, and besides, there was a timer. So this last student actually didn't have enough to form a graph either in the pre-test. But in the post-test, you can see an expansive graph for a kindergartner, and it's all centered around the fact that engineers solve problems. And this person used identity, and she said, I did it. I was an engineer. And you can see all the things that she did during that time. So while this may seem silly and not very academic research, I do have some claims that can be made from this. First of all, these are knowledge construction. E&A can actually demonstrate what they knew before and what they now know after effective professional development and units on engineering design. The first claim I can make is that not one student in the pretest said that engineers solve problems. But after those 2 5-week units, 18 students, or 33%, made that claim. Secondly, in the pretest, only 6 students said that engineers make or build something. But after those units, 50% of the class, or 27 students out of 54, said that engineers make and build. Lastly, the most important claim is called the know something category. And so what we did was we analyzed the pre-test data and the post-test data, and we looked at, is there any place we can see language or words that indicate they know something about engineering, like building or designing? And we found in the pre-test that 9 students knew something, or 17%, about engineers and engineering design. In the post-test, 45 out of 54, 83% of the students knew something about engineers and engineering design. So I'm here to claim that E&A is robust. It displays cognitive thought. It can be used with a pre-test, post-test design to measure knowledge construction. And we're actually using this in our Leadership Academy grant that we got from the Chancellor's Funds on Retention. We're actually looking at how students think about belongingness and how they think about leadership and how that changes over time and what it takes to keep students here over the course all the way through graduation. Thank you so much.